In Gaussian elimination, you just needed the bottom corner to be zeros. In Gaussian Jordan elimination, which is called reduced row echelon form, you need the bottom corner to be zeros, the top corner to be zeros, and the diagonal to be the identity matrix or ones. And if you did this, and let's say, I'll actually put numbers in here, why not? Let's say you did all of that work, and this was a 5, and this was a -1. You'd be like, I wonder what X is. I wonder what Y is. It's really, really obvious. Okay? The somewhat complicated thing about Gaussian Jordan elimination is in Gaussian elimination with 2 by 2, you really only had one step. You had to get that to be a 0. And then you solved everything on, like, logically as a result. In Gaussian Jordan elimination, you will do the same thing, but logic will force you to figure out this 0 first. Then you could divide by whatever this number is to get that 1. That'll be your second step. Once you've got that at 1, third step, you'll get that a 0. And finally, a fourth step, you will get that to a 1. It's pretty logical in its order. Should make sense when we do it that you'd have to do it in that order. But that's what's going to be our order for a 2 by 2. For our 3 by 3, in Gaussian elimination, remember you got both of those zeros first, and then you got this 0 second. We're going to go through the process and sort of undo this. This would mean that you would get this 1/3. Then you could get both of these zeros 4th. This 1 5th. This 0 6th. It's going to be a 7-step process to get it into reduced row echelon form. And if you don't do the steps in the order, you will undo a step you previously did, which means you basically have to start over again. So if we look at this first example, ooh, and I just feel like doing it. Okay. You have your matrix A. First step, we want to get this to be a 0. So I'm going to change row 2. What am I going to make row 2? Maybe I do row 2 minus row 1. That doesn't change my row 1, so I can rewrite things. Row 2 minus row 1, that does get me my 0. 4 minus a -2, that will give me a 6 there. And 16 minus 10, that will give me a 6 there. Step 1 done. Now, if you were doing Gaussian elimination, you would now change things back to its equations, right? And say 6y equals 6. I could solve for y. Then 1x minus 2y equals 10. Plug in y, you could solve for x. But in Gaussian Jordan elimination, we want to get that identity matrix. So step 2, we want to change this 6. I'll take row 2. And if I want to change that 6 into a 1, does it make sense that you would need to divide row 2 by 6? Again, my row 1 isn't changing, so I rewrite it. 1, -2, and 10. And now I divide my row 2 by 6. I still have a 0. This is 1, this is 1. Step 3, we want to get a 0 in the top right-hand corner. So now we want to change row 1. Can you see that if you took row 1 and added 2 row 2s, that would get you a 0 there. So this time, in my instructions here, I'm changing row 1, so I can keep my row 2 to the same. which is nice because that's what it's supposed to be. And row 1 plus 2 row 2's, this would stay a 1. And row 1, negative 2 plus 2, that becomes a 0. And row 1 plus 2 row 2's, this becomes a 12. And from this, we can easily say that x has to be 12 and y has to be 1. So the nice thing about reduced row echelon form is when you have your final answer, it immediately tells you what it is, okay? And you're going to make, right, I talked about matrix frustration the other class. You're going to make mental math errors. And those mental math errors are going to be frustrating because you won't know where you made them. So, if you made a mistake, and you're like, where did I make my mistake? Sometimes it's easier just to start the whole thing over again. Okay? But it has happened, I've seen it happen, that people get reduced to tears. They're like, okay, I'll start over. And they make a mistake somewhere else. And then they start over a third time. And they make the same mistake they made the first time. And then they start over a fourth time. And they're just like reduced to tears, like, hey, what's happening? So, if you're doing one of these questions, one of the things you can do is you can write your augmented matrix into your calculator. I'm going to take my calculator out and go second matrix. I'm going to edit. I'm going to make this 2 rows, 3 columns, and write this one in here. Let's see. 1, negative 2, 10. 1, negative 2, 10. And 1, 4, 16. I've got it in there. And now I can go second matrix, go over to math. If you go up, it goes to the bottom of the list. Go to reduced row echelon form, second matrix, select matrix A, push enter, and it tells us the answer. X is supposed to be 1, x is supposed to be 12, y is supposed to be 1. And then what you can do is if you're like, did I make a mistake somewhere? Like, did I make a mistake here when I have row 2? Well, y is supposed to be 1. Is 6 times 1 6? Yes. I know this is right because I can plug in the answer to check it. Obviously, it should work for this one because I haven't changed anything yet. But if you change something and you know what the answers are, you can plug those answers in and do a quick check. Did you make a mistake here or not? That can be helpful while you're in matrix frustration. You're like, what did I do wrong? You know where to check. One of the biggest things with doing this is when you make a mistake, you don't know where to check. You should see the 3x3s. All the math that you do, not allowed to make a single mental math mistake along the way. Chances for matrix frustration are actually quite high. Okay? Again, matrices, I would say that overall, there's no like super hard math going on. What makes it hard is the math is so easy that it's easy to make mistakes. So you could type this one in, see what you get, know what the answers are, set up your matrices, and go through the process of getting a 0, then a 1, then a 0, then a 1. Or you think you're ready to do some on your own? Or do you want another one together? Ready to do them on your own? Okay, try them. I will tell you the answers. And the answers are nice. So if you end up with a fraction before you get to the final thing, you made a mistake somewhere. So you did row 2 minus row 1 or something, got a 0 here. Did you get 2 and 2? Perfect. Now divide by 2, and you get 1 and 1.
That's exactly where I'm at.
And then you just have to take row 2 and add it to row 1 to make that a 0. And then you'd have to divide row 1 by 2 to get it to 1.
Right.
Notice how I did row 2 minus row 1? If you did row 1 minus row 2, it's not wrong, right? Both of those give you 0. There's often more than one way to come up with how to get it to equal 0. All right, so trying the second one here. I have the answers there. All right, I'll put up my work for the second one. Again, you might have done something slightly different. See how it's when you start with a 1 in the top left-hand corner, you sort of save yourself a step in the end. So sometimes if these two equations were written with the a plus 4b on the bottom, I'd probably still write that one first, because you can switch rows whenever you like. Do you want to see the answer for the third one? Put up the answer for the third one there. 5 and negative 1. All right, this is officially what I did. That's officially what I did. Fair view.
You froze your screen.
Oh, I froze my screen. There it is. That's what I officially did for that one. You see that you had to rearrange the equation first before you can make your matrices equation.
What do I have to do?
I'll put up all the work. This is what I did. So here with the 2 and the 3, I took 2 row 2s and minus 3 row 1s. And for the last one with fractions, I actually would multiply first to get rid of fractions. And then distribute. And I get 15, 2, 8, negative 15, 62, and 17, which are not nice numbers. But I go, well, sometimes I would do math where I would say, okay, I'm going to do 15 row 2s minus 8 row 1s and see what I get. But sometimes I'd like to just take a row and multiply it. That way it's really easy what to show. Instead of doing all that mental math and possibly making a mental math mistake, I get that 0 first. Oh, 241. But you can nicely divide by 241. And then divide by, this is supposed to be 120. And you get your answer.